Okay, we're going to find the slope of the tangent line to the polar curve r equals to tangent theta at the angle phi u, theta is equal to pi over 3. So let's first take the polar equation and change that into a parametric equation so we can talk about dy dx for the slope of the tangent line. We need to know x is equal to r times cosine theta, and then y is equal to r times sine theta. Okay? In our case, the r is the function of theta, namely tangent theta here. So what we have to do is plug in tangent theta into r. So for the x equation, we have tangent theta times cosine theta. And before we move on to the y equation, let's take a closer look. This right here, tangent theta, of course we know this is sine theta over cosine theta, right? And then we are taking this, multiplying with cosine theta. Of course, this and that will cancel out. So the x equation is nothing but just sine theta in our situation. Of course, you want to look at this rather than that, especially when we are about to do the derivative. And then we continue with y. Y is equal to r sine theta. R is tangent, so I put down tangent theta here, and we have the sine theta. But then, unfortunately, if you want to write tangent theta as sine theta over cosine theta, nothing is able to cancel out in our situation here. So let me just leave it as how it is. And now we'll proceed with the slope of the tangent line. And to do so, we need to get dy dx. And to get dy dx, by looking at this parametric equation now, we need to get dy d theta, and then we divide it by dx d theta. And then for the dy d theta, we're just going to look at the y equation and do the usual derivative. So let's go ahead and do that. This is the product of two things, tangent theta times sine theta, so we need to use the product rule. So let me put down the big fraction bar ready. For the top, it's a derivative of y with respect to theta. Product rule says I'm going to keep the first function, which is just tangent theta, but then I will multiply by the derivative of the second, which is going to be cosine theta. And then we add the second function, we just keep it as how it is, and we multiply by the derivative of the first. Derivative tangent theta gives us secant square theta. This right here is just the derivative of y with respect to theta. And then on the denominator here, I'm going to look at dx d theta. So I'm going to look at the x equation and then differentiate this. So I just have to put down what is the derivative of sine theta. Derivative of sine theta is, of course, just a cosine theta, isn't it? Okay? All right, before we proceed, let me show you what we can do to simplify this expression. For the tangent theta, of course, this is the same as saying sine theta over cosine theta, isn't it? So you see, this and that will cancel out. So we're pretty much just saying this is the same as sine theta. Right, that's the first part, and then we add it with the second part here. Nothing much we can cancel out. Let me just keep it as how it is. Plus sine theta times secant square theta. That's the numerator. And then for the denominator, we only have one thing, which is cosine theta. Let me split the fraction in the meantime. So I will just put down divided by cosine theta here, and then put it as cosine theta here in the denominator. Once again, just look at this, divide by cosine theta, and then look at this, and then divide by cosine theta. And what good does this do? First portion, sine theta over cosine theta is just tangent theta. Second portion, where I'm going to pair this up. This is sine theta, this is cosine theta. Together, that will also give us tangent theta. So we add another tangent theta. Let me put this down in red so it stands out better. And then multiply with secant square theta. Okay? So this is the expression that's going to give us dy dx, the slope of the tangent line. Okay? This is depending on the theta value, which we are given theta is equal to pi over 3. So I'm just going to plug in theta is pi over 3.
And let me just show you. I want to plug in theta equals to pi over 3, and then I will do my expression here. We have to do tangent pi over 3 plus tangent pi over 3, and then the last part is secant square pi over 3. We can refer to a right triangle. Pi over 3 is 60 degrees, so this is pi over 3. And then by looking at this right triangle, we know the ratio of the sides is square root of 3 here, 1 here, and 2 here. Tangent pi over 3, look at this right triangle. Tangent is opposite of adjacent, so we just have square root of 3. And then for the tangent pi over 3 right here, it's the same thing, square root of 3. But then for the last part, this is secant square pi over 3. By looking at this triangle, we know secant pi over 3 is 2 over 1, right? So just 2. But then we have to square that, so we multiply this by 4, right? 2 squared, because this is just the first power. We need to get the second power, so we have to square the 2. 2 squared is 4, of course.
So of course, at the end, this is square root of 3 plus, let's put the 4 in the front, and then we have the square root of 3 right here. And lastly, we can combine square root of 3 plus 4 square root of 3 as the final answer, 5 square root of 3. That's it.